So let us now see if we have two different binomial random variables, how does their sum turn out to be? So the assumption is that x1 is binomial with n1 parameters n1 and p, and x2 is binomial with parameters n2 and p. And the third assumption is that they are independent, which is that their joint probability is equal to the product of their marginal probabilities. Okay, so let's say we have y is equal to x1 plus x2. So the question is, what is the PMF of y? So this is what we have to find. So always start with the information we have. So we will have x1 plus x2 is equal to y. Now, how many ways are there so that their sum is equal to a specific value? So what we can do is we can fix one of them, and then the second one will be automatically dependent on the first one. But then x1 can be any value from 0 to, what's the maximum value of x1? The maximum value of x1 should be equal to y here. Because if x1 is greater than y, then x2 can take negative values. And we know that a binomial random variable cannot take negative values. So now we have x1 is equal to 0 to y. We use the independent property of independence assumption which we made in the start. This is equal to y minus x1. So now let's apply the PMF of both these random variables. So then we have n1 x1 n1 x1 p x1 and 1 minus p n1 minus x1 times n2 y minus x1 p y minus x1 1 minus p n2 minus y plus x1. Okay, now if I combine these two, I will have p to the y. Now if I combine these two, I will have 1 minus p n1 plus n2 minus y. And if I combine these two, I will have n2 y minus x1 and then n1 x1, and then we have summation x1 0 to y. Okay, so then these two parameters, these two values, these two parts are independent of the summation variable, so we can take them out. So 1 minus p n1 plus n2 minus y times x1 is equal to 0 to y n1 x1 n2 y minus x2. Now this guy is nothing more than the van der Waals identity which we have worked on before. So this guy is equal to the combination of the sum of these two, so n1 plus n2, and the downstairs value is this just a combination summation of these two, so just y. So then p of y is equal to y. This is equal to n1 plus n2 y p to the y times 1 minus p n1 plus n2 minus y, which means that this is binomial with parameters n1 plus n2 and p. Okay, now so what we have proved, that a sum of independent binomial random variables is a binomial random variables with the parameter of the sum of their entities, and the success probability remains the same. How about we extend it to n random variables? Um, what if we have y is equal to x1 plus x2 plus x3? So then, since we know that this guy is a binomial with some parameters and this guy is also a binomial with some parameters, so then this sum is also a binomial. So we can extend it to any number of random variables. So what is the conclusion? That if we have y is equal to x1 plus x2 plus up to xn, and uh, all of them are binomial with the parameters p, and this has the parameter n1 and n1 n2 and up to nn. So then this y is also binomial with parameters nk, k is equal to 0 to n and p. So this is a very important result, very useful if we have many problems in which we have independent random variables. The subset of a problem is a binomial random variable in which you have to add some binomial random variables in the end. So you can just directly use this identity to find the uh, overall PMF of the final solution. So that's it for now for this video. Thanks for watching. Hope you like the video.